Okay guys, welcome to my YouTube channel. In today's video, we will be revising Science Paper 2, Examination for General Certificate of Education Ordinary Level, Examinations Council of Zambia ECZ. So we'll be revising this Science Paper 2, paper which was done in August 2019 by GCE candidate. So this is a very cardinal paper and you should pay attention up to the end of the lesson so that you learn one or two things to help you pass your examination. So let's go straight into the video. All right, so question number 1 says 50 cubic centimeters of sample of alcohol is mixed with 50 cubic centimeters of water. So here you have 50 cubic centimeters of alcohol being mixed with 50 cubic centimeters of water. So they're saying the volume of the mixture is found to be 97 cubic centimeters. Which of the following is the best explanation for this observation? So they're saying they mixed 50 cubic centimeters of alcohol with 50 cubic centimeters of water, expecting to get 100 cubic centimeters of the mixture, but they got just 97 cubic centimeters of the mixture. So they're saying which of the following is the best explanation for this observation? So A, they're saying some alcohol molecules evaporated. B, the alcohol molecules fit into the gaps between water molecules. C, water and alcohol react to form a gas which escapes. Then D, water and alcohol react to produce a salt which then dissolves. So the best answer here is B. So the reason why the volume didn't go to 100 cubic centimeters is that since water molecules are large, they leave spaces in between them, and molecules of alcohol are very small, so they had to fit into the spaces that were between water molecules. That's why the volume did not reach 100, but it went to 97 cubic centimeters. All right, so let's go to another question. So question A2 reads, a mixture of Q contains 3 compounds T, U, and V, whose solubilities in ethanol and water are as shown in the table below. So we have compound Q, which contains T, U, V, and then the solubility of these things are that in ethanol, T very soluble, then U insoluble, then V insoluble as well. Then in water, T sparingly soluble, which means slightly soluble, then U very soluble in water, then V insoluble in water. Then the question says, how do you separate the mixture Q to obtain pure crystals of compound U? So you want to get a pure crystal of compound U from these other mixtures. So they are saying A, add ethanol. So when you get ethanol, you add to Q. What things are going to dissolve? Compound T will dissolve. Then what else will dissolve? These two will not dissolve, so you remain with these two. Then you filter, you remain with these two. So you only get compound T. When you dry, then you remain with U and V because these are insoluble. So not true. Let's see B. Add water. So you add water. Then when you add water, what will happen? This will dissolve as well in water because it is slightly soluble, and this will dissolve. Then this V will not dissolve. So after that, so you have these two which will dissolve. Then you do what? You filter. So you have a solution containing this and this. Then it crystallize. So meaning it will not be a pure crystal of U because there will be U and T in this process. So let's go to C. C is saying add ethanol. So you add ethanol and filter. So when you add ethanol, this will dissolve. So these two will remain. So you filter. So when you filter, then this one will come out because it will dissolve. Then again you add water because you remain with these two. So when you add water, you remain with these two. So this U will dissolve. This one won't dissolve. So then you filter. When you filter, you get a solution which will crystallize. So this will remain on the filter because it is not soluble. This will pass through. When you crystallize, which means you are crystallizing this solution, then you correct this one. Yeah, this is correct. So our answer here should be C. So let's go to another question. Question A3 reads, the chemical formula of ammonium sulfate is, so the chemical formula of ammonium sulfate, it's actually C. Why? Because what you should understand here is that ammonium, this one here, has a formula such as NH4, and that has a valence of 1, and this sulfate has a formula as ACO4 and has a valence of 2. So when you're deriving the formula here, you swap the valences like this. So this one should come here, this one should come this side. So since this one will be shared, so it will be like NH4, then you do like this, it's a radical, then this 2 comes here, then you get this one ACO4, then this one, when it comes like this 1 times everything in the brackets to be the same, so this formula will come to as NH4 2 SO4, which will be C. All right, so let's go to another question. F4 reads, the atoms P, which has a relative atomic mass 31, atomic number 15, and the S, which has a relative atomic mass 32, atomic number 16, have the same A, nucleon number, B, number of electrons, then C, number of neutrons, D, number of protons. So what is the same here? So if we get relative atomic number minus 15 here, we get 16, which is the number of neutron. Again, if we get 32 minus 16, we'll get 16, which is the number of neutron. So here 16 number of neutron, here 16 number of neutron. So these will have the same number of neutrons, which will be C. Then F5 says, which pair of elements can combine chemically to form single covalent bonds? So covalent bonds is a type of bonding which occurs in nanometals by sharing outermost electrons to form compounds. So these compounds which are formed by covalent bonds can have triple bond, single bond, then tetra. So they're asking us to say which pair of elements can combine chemically to form single covalent bonds. So this hydrogen and nitrogen, yes, potassium and oxygen, this won't be covalent because it will be between potassium and oxygen, which is potassium metal, oxygen nanometal. So this is ionic. Then oxygen and the carbon dioxide, these they will have double bond. Then sodium and chlorine, no, this one is ionic, so the best answer is A. So let's go to the next question. A6 says, which one of the following is not an example of a mineral acid? So sulfuric acid is a mineral acid, nitric acid is a mineral acid, hydrochloric acid is a mineral acid, citric acid is not an example of a mineral acid. So yeah, so this is the answer. A7 says lead 2 iodide is a yellow insoluble salt. Which of the following should be reacted with lead 2 nitrate solution to produce lead 2 iodide? Alright, so they want us to find out what should be reacted with lead 2 nitrate to produce lead 2 iodide, this salt which is insoluble. So they have given us one reactant here, which is this one. They have given us one reactant which is lead 2 nitrate. So we have lead 2 nitrate, and this salt which we need to form here, this lead 2 iodide, it is an insoluble. So insoluble salts are prepared by the process known as double decomposition or precipitation, and the reactants that are needed to form an insoluble salts must be soluble salts. So this lead nitrate is a soluble salt, so it needs another soluble salt from this to combine and give this salt here. So if you have lead like this one here, lead nitrate to so we are looking for a salt which it should combine here. So definitely it should combine with potassium iodide here, potassium iodide. Sorry guys, this is why I use this method, because I cannot write properly. So this is potassium iodide. So potassium iodide. So this potassium iodide, what do? They exchange ions. So lead will get on this to form what? Lead 2 iodide. Then this will get on this one to form potassium. So this salt lead iodide will be insoluble, which will be this salt they need. So the answer here is going to be D. Let's go to another question. So question A8 says zinc hydroxide can react with sodium hydroxide because it is acidic, amphoteric, basic, neutral. The answer is B. When you look at this zinc hydroxide, it should be a base in this case. That's how we know it. But it is reacting with another base. So it is behaving as an acid. So such a compound, we call it amphoteric. Alright, so let's go to 9. 9 says calcium burns in oxygen according to the following equation. So we have 2 atoms of calcium solid plus 1 molecule of oxygen gas reacting to form 2 moles of calcium oxide. Then they're saying if 5.2 grams of calcium burns completely, what will be the mass of calcium oxide produced? So this, which is given as the 5.2 grams, react completely with the oxygen, because they're saying if 5.2 grams of calcium burns completely, meaning this one is a limiting reagent, this one is an excess, because this one burns completely. So they're saying what will be the mass of calcium oxide produced, this mass here. When this react with this, what mass of this will be produced? So remember, the mass of a product formed is dependent on the limiting reagent, which is actually calcium oxide, which is a limiting reagent is actually a reactant or reagent that is used up completely in a chemical reaction. So in this case, this one burns completely. So it is the one that will determine the amount of calcium produced. So what we are going to do here to be able to find the amount of calcium oxide produced is to find a mole-to-mole relationship between this calcium atom with calcium oxide using what we call stoichiometry. So if you want to learn more about stoichiometry, you can click on the video whose link is appearing here. Alright, so we are going to say number of moles of calcium. This N stands for number of moles. So I read it as number of moles of calcium atom divided by the stoichiometric mole ratio. So the stoichiometric mole ratio, it is this number in front of it. So say over 2 is equal to, so we relate it to this product. So we are also going to say number of moles of calcium oxide divided by the stoichiometric mole ratio, this one to here. So these two and these two, since they are the same, they will cancel. So remain with number of moles of calcium is equal to number of moles of calcium oxide. This is very important because for you to be able to calculate the mass of calcium oxide produced, you must first know the number of moles of calcium oxide. So how will you know the number of moles of calcium oxide? You use the stoichiometric mole to mole relationship like this one I've created between what is given and what is not given. So in this case now, this one we can read as number of moles of calcium is equal to number of moles of calcium oxide. Meaning, if we are able to know the number of moles of calcium, that means that number of moles will also be equal to the number of moles of calcium oxide. So here what we are going to do, it is first to calculate the number of moles of calcium, because we know calcium is the substance whose mass has been provided. We are told 5.2 grams of calcium burns. So it's this one burning. So we find its number of moles we put here. Then it will mean it is also the number of moles of calcium oxide. So we have this formula that we use to calculate the number of moles, which says number of moles is equal to mass over molar mass. All right. Again, if you want to learn more about this introduction to mole concept, click on the video whose link is appearing here. So this one is called the number of moles is equal to mass over molar mass. So since we want to know number of moles, we'll say number of moles is equal to mass of calcium, which is 5.2 divided by molar mass of calcium, this calcium here. Its molar mass or relative atomic mass, it is 40 when you check from the periodic table. So it will be 40 grams per mole. Then you are going to divide this gram and this gram will cancel. So you remain with it, just mole. So we have 5.2 divided by 40, you get 0.13. This mole will come here. So meaning this is the number of moles of calcium in this reaction. So what we are going to say, number of moles of calcium here then is going to be 0.13 mole, which we introduce the equal sign here, which is the same as the number of moles of calcium oxide. So having known that number of moles for calcium is 0.13 mole, this is also equal to the number of moles of calcium oxide. So which means the number of moles of calcium oxide is also equal to 0.13 mole. All right. So now we will use this number of moles now to calculate the mass of calcium produced. What will be the mass of calcium oxide produced? So we use the same formula here. Now we'll make M, which is mass, the subject of the formula. So we'll say mass is equal to a number of moles times a molar mass. So you need to know how to change the subject of the formula in science, and I already did a video here how to change the subject of the formula. You can click on the link appearing here to also learn more. So once you make M the subject of the formula, now you substitute, you say M is equal to, where there is number of moles, you put this one 0.13 mole, then times, then molar mass for what? For calcium oxide, which will be actually 56. Why 56? Because what you should know here is that calcium has a molar mass of 40. So calcium has a molar mass of 40. Okay, so this calcium has a molar mass of 40. Then oxygen, this one has a molar mass of 16. So you say plus 16. So when you say plus 16, you add, it will be 56. So this is the molar mass here. So you multiply 0.13 times 56, then you find the answer. This more and more will cancel, you remain with grams. So mass is going to be 7.28 grams. Then, since whatever we are given here is according to 1 decimal place, we also round this one to 1 decimal place. So say mass is equal to 7.3 grams, which means our answer is B. Let's go to another question. So we have A10, which says barium sulfate is best prepared by. So barium sulfate, it is an insoluble salt. So insoluble salts are prepared by precipitation. So our answer is D. 11 says the order of the reactivity of the elements below starting from the list is. So first of all, you study the elements, especially looking by their outermost shell. So the outermost shell in this atom has got a 1 electron, which means that it is of a metal. Then this one has got a 4 electrons, which means it's a nanometal. This one has got 1 electron, which means that this one, it is also a metal-like. So you know that most metals are more reactive, and the more with metals, the less electrons they have in the outermost shell, then the more reactive they are. And also, the more shells they have, the more reactive they are. Then for nanometals, the less number of electrons they have in the outermost shell, then the lesser reactive they are. So this one, it's a metal, it has less number of shells. So this, when we compare Z and X, X is more reactive than Z. Now this one is a nanometal, which is not even very reactive. So if they are saying the order of the reactivity of the elements below starting from the list is, so the list should be this one, then followed by this one, then the highest is this one. So Y, then Z, then X. So Y, Z, X, C as our answer. So let's go to another question, which is A12. A12 says, which of the following explains the importance of catalysts in chemical reactions? So what is the importance of catalysts in chemical reactions? A, they are saying enable the activation to be lower. Yeah, this one should have been activation energy, maybe typing missed out activation energy here. Then B, to enable reactants to be consumed completely, not really. C, help to conserve reactants and products. No, reactants must actually react to form products. Then D, offer more energy for reaction to take place, not really. So the best answer is A, though I missed something here, maybe in retyping, because the original past paper was not clear, so I had to retype this one. So meaning in my typing, I missed out activation energy here, because the function of a catalyst in a chemical reaction, it is to speed up the rate of a chemical reaction by lowering the activation energy needed for reactants to form products. So A13 says an element was described as shown in the table below. Which description is correct about the element at RTP? RTP stands for room temperature and pressure. So let's look at here, number of shells, valence period, group, state. So state solid, gas, liquid, solid. So group 3, 6, 3, 5. All right. So number of shells and periods, they are always the same. Then valence and also groups, they're always the same. So here, number of shells, period, it's not matching. So this is actually logical. We can't waste our time on it. Then here, number of shells, 3, period 3, yes. Then valence 3, group 3, not true. I mean 6 here, they are not matching. Where is it matching on it? Number of shells 3, period 3, yes. Then valence 5, group 5, yes. So this one, again, they're saying it is solid, yes. When you check on the periodic table, this must be phosphorus. So our answer is D. We go to another question. F14 says, which of the following sets corresponds to a metal and the main ore from which it is extracted? Let's read again. Which of the following sets corresponds to a metal and the main ore from which it is extracted? Okay, so we have a metal here and the ore from which it is extracted. So which one is correct here? So zinc, calamine, yes. The ore from which zinc is extracted is calamine or zinc blend. Here iron, they're saying bronze, no. This is actually an alloy. Copper, magnetite, no. This magnetite is actually from iron. Then aluminium, hematite, no. Hematite is actually for iron. So the correct answer is A. Then A15 says, which of the following observations most strongly suggests that a solid element X is a nanometal? So A, X reacts vigorously with chlorine. All right, let's continue. B, X is a conductor of electricity. No, nanometals are not conductors of electricity. Then X forms an acidic oxide. Yeah, nanometal forms acidic oxide. Then DX has more than one valence. Yeah, but nanometals shouldn't have more than one valence, more than 3 valence electrons. So the answer is C. So let's go to another question, which is question 16. Question 16 reads, nitrogen is used to produce ammonia gas as shown in the diagram below. What is X? All right, so here we have nitrogen should be mixed with another element here to form ammonia. That element should be hydrogen, which is B. So nitrogen plus hydrogen when mixed at 400 degrees Celsius and the catalyst with pressure of 200 atmospheric, ammonia must be formed. Okay, so let's move to 17. 17 says ethene, which is C2H4, burns completely in air to form carbon dioxide and water. What is the balanced chemical equation for the reaction? So the balanced chemical reaction for the reaction is actually D here. Then A18 says the organic product of the reaction between, this one should be an alcohol, which should be methanoic acid, plus this one should be a carboxylic acid, which should be this one should be alcohol methanol, yeah. Then this one methanoic acid. So these two, when they react, an alcohol and an acid, they form an ester. Yeah, they form an ester whose formula is B. Then let's go to 19. 19 says choose the correct monomers for pterylene. Actually, it is alcohol and the carboxylic acid. These are monomers, small molecules that when you join together, they'll give you pterylene. So let's go to question number 20. A20 says the displayed structural formulae below are of different compounds. Which ones are isomers? So you should know that isomers are organic compounds that have the same molecular formula but different structural formula. So of these ones here, which one have different structural formula but the same molecular formula? It is actually these B, V and X. So V has got the same molecular formula because it has the same number of what's this? I mean carbon atoms. There are 1, 2, 3, 4. Even here 1, 2, 3, 4. Then the hydrogen here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Even here 1, 2, 3. I mean 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why these they will have the same molecular formula like this. So have a number of carbon, it will be 4. Then the number of hydrogen atoms, it will be 10. So this one is called the molecular formula, which will cater for this one and this one, not this one. This one have 1, 2, 3, 4, 5, 6, 7, 8. Then this one has 1, 2, 3, 4, 5. So it will not match. So let's go to another question. So we are now in section B. Section B, 45 marks. They are saying answer all the questions in this section. So they are saying B1, write your answers in the spaces provided on this question paper. So they're saying the table below shows some common gases and their particulars. So we have gases here: ammonia, carbon dioxide, helium, nitrogen. Then relative molecular mass: for ammonia 17, for carbon dioxide 44, for helium 4, for nitrogen 28. Then vapor density for ammonia 8.5, for carbon dioxide 22, for helium 2, and for hydrogen 14. Then the question they're saying is, choose from the list given the gases that best suits the following description. A gas may be chosen once, more than once, or not at all. So A1 says the gas that diffuses fastest. So the gas that diffuses fastest in here, it must have the lower vapor density of the vapor itself, and also lower relative molecular mass. So in this case, it will be helium. They need to, they are saying the names of the gases that diffuses or that diffuse at the same rate. So looking at these, I don't think I can see gases that have the same relative molecular mass and the same density. So here I said none of the above. Excuse me. Then B, they are saying state the name of the gas that would diffuse faster than any other gas shown in the table. So the other gas that we know that is lightest on Earth is actually hydrogen. So hydrogen, if it was placed here, it will be the lightest actually gas, and it will diffuse faster. All right, so let's say hydrogen. Then let's go to another question. So here they are saying, C, what is the relationship between the relative molecular mass of a gas and its vapor density? All right, so we are saying that the larger the relative atomic mass, the larger the vapor, and the vapor, and vice versa. So here I should have said the vapor density, sorry. Then D, under what conditions would carbon dioxide diffuse faster than ammonia, both of equal volumes? So it could be that when the temperature of carbon dioxide is increased, that's when you would expect carbon dioxide to diffuse faster than ammonia, because carbon dioxide, as we have seen previously, it has more relative atomic mass than ammonia, so it is heavier So meaning for it to diffuse faster unless you increase its temperature to actually increase the rate of diffusion. All right, so let's go to another question. So this is question B2, which says the following, the diagram below shows the preparation of liquor in a village. So yeah, preparation of liquor in the village. So we look at it properly. Then A, they are saying name the process demonstrated above. So liquor here, they are making some kind of beer here, which is cachaso in particular, I think. That's how they make it. Then this is made by the process called fractional distillation. So B, name one, B1, name apparatus B. This apparatus B here, it is called a condenser. Then 2, if this experiment was done in the school laboratory, what name would be apparatus A and B? So this apparatus A here, I think it could be a round bottomed flask, and then B, this one here, it will be a Liebig condenser. Then they're saying what is the scientific term for the liquor or liquid in the experiment? This liquor here being produced here, so the scientific name is alcohol. So let's go to another question. B3 says aluminium metal was reacted with aqueous copper 2 sulfate. So aluminium metal was reacted with aqueous copper 2 sulfate. Then A, they are saying construct a balanced chemical equation for the reaction, include state symbols. So we'll start. So aluminium is a metal. So say aluminium as a metal, it is a solid, plus copper 2 sulfate, aqueous copper 2 sulfate. So aqueous in a liquid form, so it will be copper 2 sulfate is like CuSO4 aqueous, because it is aqueous here. Then these two, when they react, they will displace each other. So this actually will be a displacement reaction where a more reactive metal will displace a less reactive metal from its compound or from its salt in aqueous solution. So this aluminium is more reactive than copper, even when you check on the reactivity series. So since this is in aqueous, so this will displace this form aluminium sulfate, and copper would be displaced. So it will be like this equals to, then copper solid will be displaced as a metal, plus then we'll have aluminium sulfate like that. Then they are saying we construct a balanced equation. So we have included the state symbol. So check aluminium here, it is 1. Here it is what? 2. So put a 2 here. All right, aqueous there. Yeah, we'll put where? A 2 here. Then what we are going to look at again is this one. Sulfur here is 1. Not so. When you come here, it is with this 3 here, it means it is 3. So put a 3 here, balance it also. So this 3 will affect what? Copper here. So copper here will be 1, but here it is 3. So put a 3 here. So it is balanced. So aluminium 2 here. Okay. Then what else? This one, copper 2 here. 3, even copper 3 here. Then sulfur 3. This 3 is in front of also S. Even in this S here, there's a 3 outside here, so it is a 3. Then oxygen here, it is 4 times 3, 12. Here also oxygen 4 here times 3, 12. So it is balanced. Then B, they're saying deduce an ionic equation from A. So we deduce an ionic equation. So when you are writing an ionic equation, you actually split these reactants or species in aqueous solution. So this one you split in between here and this one in between, you write them in ionic form showing their charges as they exist in aqueous solution. So these which are not in aqueous solution, they are not split. So you write aluminium solid plus, so this one will be split here, so have 3 copper charge 2 aqueous, you get aqueous, you give this one, then since you have split here you say plus again, the other part you have split, since this 3 is being shared by everything here, you say 3, then you write sulfur. Now you introduce a charge -2, that's a charge of sulfur, you write aqueous again here equals, this one won't be split because it is in solid, so it will be 3 copper solid, then this plus, so this since it is in aqueous it will be split here. Moreover, now these 2 must come in front here to show that 2 atoms of aluminium, so you say 2 aluminium atoms, then what will happen, plus aqueous, you say aqueous plus now this other one here also, since there's a 3 here, you put a 3 in front, then you write the sulfur aqueous. Then what you do, you cancel out ions that appear on both sides of the equation. So here you can see we have sulfur here in aqueous and sulfur here in aqueous, so it will cancel. Sulfur and sulfur here should cancel, then we remain with aluminium here plus copper, then aqueous, this will give us then copper here plus this aluminium here aqueous. So this is balanced. When you look at it, aluminium here 2, aluminium here 2, copper here 3, copper here 3, and the charges here 2 times 3, which is 6, even here 2 times 3, 6. So that's how it's supposed to be. Let's go to another question. Question B4 says aluminium hydroxide, calcium oxide, sodium hydroxide, sulfuric acid, anhydrous calcium chloride, then anhydrous copper 2 sulfate, iron 3 oxide, and calcium, sodium carbonate. Then they're saying A, from the list given above, choose one substance which is deliquescence. So like a deliquescent substance is a substance that actually loses its water of crystallization to the environment. It is a substance that absorbs water from the environment, so and form a solution. So this is actually calcium chloride. Then hygroscopic substance in these they have given us here, an hygroscopic substance is a substance which also absorbs water from the surrounding, but it does not actually lose its state. So an example here, it is actually sulfuric acid. Then 3, they're saying neither deliquescent nor hygroscopic. So this one is aluminium hydroxide. There are many, even iron oxide is known to be like that. Okay, so even this, I think copper. So B, they're saying what is the difference between a deliquescent and a hygroscopic substance? So this is the difference, that a deliquescent substance changes state when it absorbs water, while a hygroscopic substance does not change state when it absorbs water. Then C, some substances are said to be efflorescent. What is an efflorescent substance? So we are saying these are substances that lose water of crystallization to the surrounding. Let's go to another question, which is question B5. B5 says a learner reacted a certain mass of magnesium with 150 cubic centimeters of dilute hydrochloric acid. 240 cubic centimeters of hydrogen gas evolved at room temperature and pressure. Then they are saying A, construct a balanced chemical equation for the reaction. So we need to construct a balanced chemical reaction for the we need to construct a balanced chemical equation for the reaction. Which reaction? Reaction of magnesium with dilute hydrochloric acid. So what we should know is that when we have magnesium, it is a solid. They are saying a balanced chemical reaction, which means no state symbols. So plus hydrochloric acid, it should give us magnesium chloride plus hydrogen gas. Now they need us to balance this equation. Make sure you realize that here you have 2 hydrogen, here you had 1, and the chlorine 2, here 1. So you need to put a 2 here so that you balance the hydrogen and the chlorine. Then B, they're saying calculate 1, the number of moles of hydrogen in 240 cubic centimeters of the gas. So meaning when this and this react, they produce magnesium chloride and hydrogen, and the volume of hydrogen they produce is this one, 240 cubic centimeters of hydrogen gas evolved at room temperature and pressure. So it was produced. Then they're saying how much, or we calculate the number of moles in this volume of the gas or hydrogen. So what you should know is that there's a formula here which says number of moles is equal to physical volume over volume at RTP. So this is actually also what we call molar volume as well at RTP. So at RTP, 1 mole of a gas occupies 24 cubic decimeters of volume. So now, if we are told that at the same temperature here, room temperature and pressure, 240 cubic centimeters of the gas was produced. How many moles were there? So we can use this formula. So we can say this is this volume, this is the volume at RTP for 1 mole. How about for this one? So we'll say volume or number of moles is equal to this volume converted into cubic decimeter by dividing by 100. If you get, for example, you get your this one 240, you want to change it into cubic decimeter, so you divide by 1000, so you get 0.24, which will be the physical volume here. So this volume here divided by molar volume at RTP, which is 24, it will be what? 0.01 mole. So there are 0.01 mole of hydrogen gas in 240 cubic centimeters. Then B2, they are saying we also calculate the mass of magnesium used in the experiment to produce 240 cubic centimeters of hydrogen gas at room temperature and pressure. So this gas which was produced with this number of moles here, how much magnesium was reacted? So again, we need to correct or make a mole-to-mole relationship between the reactant they're asking us to find the mass for, and also the product whose mole we know, number of moles we know. So we'll say number of moles of magnesium over 1. Where are we getting the 1 from? Which is the stoichiometric ratio in front of magnesium. In case of 1, we don't write a 1 here. So when there is no number in front, just know that there is 1. Then we'll say equals to, then this one, number of moles of hydrogen over 1. There's also a 1 in front here that we don't write. Now, if we divide 1 into this one, it will give us the same number of moles of magnesium. 1 into that, it will give us the same number of moles of hydrogen we know. Number of moles of hydrogen here, we have already calculated here. So we get it and push it here. So the number of moles of magnesium is equal to number of moles of hydrogen, which we calculated here. We should put it here, which means that it is also the number of moles of magnesium, because this is saying number of moles of magnesium is equal to 0.01 moles. So from here, now we are going to get the formula that we use to calculate mass. So this formula says number of moles is equal to mass over molar mass. Since we are looking for this mass here, we'll make it the subject of the formula as mass is equal to number of moles times molar mass. Then we'll substitute number of moles, it will be this molar mass for magnesium, which is 24 when you check on the periodic table. So it will be mass is equal to number of moles, we'll put this value, molar mass 24. When we multiply the 2, we'll get mass is equal to 0.24 grams, which is the mass of magnesium used in the experiment to produce this. Then let's go to another question. If you are finding value in this video, don't forget to give it a like. I will appreciate greatly. If you are new to this channel, consider subscribing, because I will do a lot of videos before you write the exam. So to avoid missing them, subscribe so that YouTube sends you a notification whenever I upload a new video. So B6 says, study the two diagrams below showing different sizes of sodium metal. So we have sodium metal A, sodium metal B. These are bigger particles, these are smaller particles. Then A1 says, which diagram would sodium react faster if put in a beaker containing water? So between A and B, B will react faster. So they are saying to give a reason for your answer. The answer is that B contains smaller particles which provide a large surface area for the reaction. So smaller or rate of reaction actually is affected by the size of particles. The smaller the particles, the faster the reaction will go. Alright, so B says, state one other factor that can affect the rate of this reaction. So another factor here can be concentration, temperature, or catalyst. Concentration. Yeah, concentration actually affects reactant in solution. I think here I should have erred here. So Where is the ink now? Guess here. So this one must be an error, because concentration must only affect reactants in solid. Okay, so reactants in liquid are the one concentration affects. So the other factor here should be temperature or catalyst. Okay, so let's continue. C says state the effect of a catalyst on the activation energy. So the catalyst lowers the activation energy. So let's go to another question. Below, B7 says below is a skeleton diagram of the periodic table. Skeleton diagram of the periodic table. A, give the name of the region marked X on the periodic table. This region here between group 2 and group 3, this region here is called the transition metal. Then B, give any two general properties of elements found in the region marked X. So they want any. So 1, we are saying they are good conductors of heat. 2, they have high melting and boiling point. Okay, so you could have said they are malleable. Then you could have said they conduct. You could have said they're used as a catalyst, something like that. Or here it's not used as actually properties. You can say they are sonorous, malleable, ductile. Yeah, it could also suffice here. Then C, state any two uses of the elements found in the region marked X, the same transition. So we said 1, they are used as conductors of heat and electricity. 2, they are used as catalysts. All right. So let's continue. B8 says generally some metals easily corrode when exposed to certain conditions. So explain what is meant by corrosion. So corrosion is a chemical wearing out of metals due to exposure to certain conditions. Yeah, so when metals are exposed to certain conditions, then they undergo a wearing out process called corrosion. Then B says which of the metals Z, potassium or copper corrodes faster when exposed to certain conditions. Actually, the answer is potassium here. Then they're saying give 2 reasons. Okay, so before I give 2 reasons here, let me explain why potassium. So of these metals given here, potassium is the most reactive metal. So the more reactive the metal is, then the more corrosive it is. Okay, so see, they are saying give 2 conditions that easily promote corrosion. So it is water and oxygen. So corrosion happens in presence of water and oxygen. So D, they are saying give 2 methods of preventing corrosion of metals. There are so many methods. So here I just gave you these: painting, greasing, plastic covering, electroplating, or sacrificial protection. These are some of the methods that are used to prevent corrosions of metals. All right, so let's go to another question. Question number B9 says carbon is asymmetrical and exists in many forms of allotropes. So what are allotropes? Allotropes are the different forms in which a substance can exist in the same physical state. So like the way carbon is, it can exist in different structural form in the same physical state solid. So B, they are saying give 2 examples or give 2 crystalline allotropes of carbon. So we have diamond and graphite. C. Give one property and the use based on the property of the allotropes you have named in B above. So we will pick one. Let's say we picked for graphite. So we are saying graphite is used as a lubricant for engines and locks because it is soft and slippery. So you could have also said graphite is used to conduct electricity in cells, as in what's this? Electrodes. So graphite is used as electrodes in batteries or cells because graphite is actually a good conductor of electricity. It has free mobile electrons, or you can say graphite is used in the manufacture of pencils because graphite is soft. When it is mixed with other substances, they can make the pencil. Diamond, it is hard. It is used for cutting. So it is also, it has a good appearance, so it is used in jewelry. So you could have said those.